by the points on the unit circle. Where do they come from? Let's find out right now. Hey, it's me again, your instructor. So, you watched the other video hopefully several times. Instead of sitting in class doing it, you're sitting at home, you're in your jammies, or you're riding down the road looking at it on your cell phone, whatever. Hopefully you're not driving and looking at it on your cell phone. Never text and drive. But anywho, here we go. The unit circle, x squared plus y squared equals 1. Again, this is the equation of a circle from algebra land with a center at the origin, 0, 0, and a radius of 1. So what I've done is given you the unit circle, and there's a lot of parts to this, but let's go ahead and get the points down that we should already know. Like for example, right here, this is the ordered pair 1, 0. Here's the ordered pair 0, 1. Reflecting it, we should know this is the ordered pair negative 1, 0, and here's the ordered pair 0, negative 1. Those are pretty simple points to find. So now, let's go through the rest of it like I showed you before. 1, 2, 3. Or if you want to do square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, you can do that, but it's 1, 2, 3. It's 1, 2, 3. That's simple. Oh. And then this is, of course, divided by 2, divided by 2, divided by 2. That's the square root of 3, square root of 2, square root of 1. And then the next values, you're just reversing them. So he goes there, there's 1/2. This one is square root of 2 over 2, which you should know, that's 45, 45. And then this one would be the square root of 3 over 2. So these two are really the 30, 60, 90, or the 60, 30, 90, depending on which orientation you have. So now, let's find the rest of these ordered pairs, and they're very simple. If you have 1, 2, 3, 1, 2, 3, you've got this, practice it. I know you can print this out on the internet. You can get a tattoo of this thing if you want to, and you're 18 and you got enough space to put all this up there, but just 1, 2, 3, push yourself. Come on, because you're going to be competing with other people a lot smarter than me that's going to already have this stuff down pat like the back of their naughty little head. So this point right here, it's the same point. We go to the y-axis and jump over. So that just negates the x value right there. Same ordered pair, but it's the x values, the cosines, that are negative in that quadrant. So this ordered pair comes right over here. This is negative square root of 2 over 2, positive square root of 2 over 2. And then that ordered pair just jumps right there. That is negative square root of 3 over 2, 1/2. And then we do the same thing for this one. We're just going to drop them down here. So this one, ordered pair right here is going to jump right there, that same distance. So now it's the y value that's negating. So we know that the x and y values in the third quadrant are both negative. So that's negative square root of 3 over 2, negative 1/2. This is, of course, negative square root of 2 over 2, negative square root of 2 over 2. And then this one, there to there, would be negative, right here, there to there would be negative 1/2, and then down negative square root of 3 over 2. And then last but not least, we just take these and reflect them over the x-axis, or we could take these and reflect them across the origin, or we could take these and reflect them across the y-axis. There's so many reflections, so little time, it doesn't really matter which one you do. If you want to reflect this one over the origin, that negates both of them. So that means it's negative 1/2, which is positive 1/2, and negative square root of 3 over 2. Now if that confuses you any, just say, hey, I take this ordered pair and reflect it down. It's the y value that's negated. So this one right here, there to there, would be square root of 2 over 2, negative square root of 2 over 2. And then last but not least, right here, we have this ordered pair, bloop to bloop. So this is square root of 3 over 2, negative 1/2. Those are your 16 points. Now the question is, if I said, what is the cosine of a 330-degree angle? You might go, 330 degrees is all the way around here, so the cosine is going to be the square root of 3 over 2. It's that simple. Oh my. So in other words, using your special right triangles, if the cosine of a 330 degree is the same as finding the cosine of a 30 degree, so that's your reference angle, so you're going to draw that special right triangle, then you're going to use your adjacent over the hypotenuse, then you're going to decide whether or not it's positive or negative. The unit circle takes care of all those steps. So again, if you're going to find the reference angle, then you're going to use the special right triangle, decide where it's positive and negative, or memorize the unit circle. Blah, you got it. Who are you? No imaginary numbers in this class right now. And X is the cosine, Y is the sine. If you're not sure about that, go back and look at your textbook for the definitions, or look at the last video I just created. So now, let's get all these different ordered the angles, and so forth. So this one right here, this is 45 degrees. So a reference angle of 45 degrees would be 135. 180 plus 45 is 225. 360 backed up would be 315. So 45, 135, 225, and 315 are all the angle measures in degrees that have a reference angle of 45 degrees. Now how do we write them in terms of pi? It's pretty simple. Since this is 1 pi right here, which is 180 degrees, half of it would be half pi, or 90 degrees, so half of that would be pi over 4 radians. So watch this. 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 6/4. 6/4 is 3/2 pi, which is 270 degrees. So 6/4, 7/4, 8/4. 8/4 is 2 pi, which was originally 0, but it could be 360 degrees, all that good stuff. So 1/4 pi, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. It's that simple. Let's do the 30 degrees. So this is 30 degrees, 30, 60, 90, 120, 150. So I'm increasing by multiple 30 degrees, 180, 210, 240, 270, 3, increasing by 30, that's 300, 330, 360. In other words, I skipped count by 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. And I could keep on going, couldn't I? 390, 420, 450, 480. Oh yeah. Oh, I could do negative. This could be actually negative 30. But keep in mind, negative 30 and 330, those are coterminal angles. They both have a reference angle of 30 degrees. Very cool. Now you're saying pi's are hard. No, they ain't. 30 degrees is 1/6 pi. 1/6. So just do it like that. 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi, 5/6 pi, 6/6 pi, 7/6 pi, 8/6 pi, 9/6 pi, 10/6 pi, 11/6 pi, 12/6 pi. I said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 6th. And then you can go through here now and say, well, 2/6 is really just 1/3. 4/6 is really 2/3. 5/6, 7/6, 8/6 can be reduced. That's 4/3. 10/6 is 5/3. And there you have it. I'm not smart enough to memorize all these weird different things. So I don't memorize it. I learned it. So when people say you shouldn't memorize, well, you have a choice. You either need to learn the material or you have to memorize it. Learning it and being able to construct it is, to me, better than memorizing. Now, you don't have an option. If you decide to do neither of them, well, then you're going to be as dumb as then you were when you started the class. You're taking a class and trying to find the right answers to the questions by using Google and everything, or using a calculator. You're not learning. So let me plead to those of you watching this video. Look at what I did. Be able to construct this, because that's really what happens in real life. You're faced with problems all the time that you can't Google a simple answer to. why don't people like me, or how can I be accepted? Not that you should worry about that stuff, because I certainly don't. But you're going to be faced with problems that you've never encountered before. And being able to navigate it and construct new ways of doing things. I mean, look at what I did. That's an entire unit circle right there, which is pretty awesome. So yeah, the unit circle is not scary. I'll put some additional notes up. But again, watch this video several times. Think about how I got all these little pieces in here. So now, hey, the unit circle affords us a couple of extra things. What is the sine of 0 degrees? 0. What's the cosine of 0 degrees? 1. What's the tangent of 0 degrees? Sine over cosine's tangent, so 0 over 1 is 1. The tangent of 90 degrees would be 1 over 0, which is undefined. Unit circle's pretty awesome, but then again, so are your special right triangles. And being able to decide which one you want to use is entirely up to you. But some have their advantages, and others, they have their little drawbacks. Until next time, this was the unit circle.